Now it should seem fairly easy. Okay, at least that's the vibe I got from last hour. But we're going to be determining whether functions are continuous, discrete, or neither, and determining whether functions are linear or nonlinear based on their functions or tables of values. So this chart is directly out of the textbook, so if you need to refer back to it, there's further explanation there. But it should contain all the information that you need. So a discrete function we were dealing with yesterday when you were plotting specific points and you were looking at the domain and the range values. So a discrete function is just a set of points that are not connected. Okay? So any set of dots, there's no connection between them whatsoever. Okay? A continuous graph, all the points are connected, it's on a line or a curve, it doesn't matter, but there's no broken part of the graph. It's just a continuous line from the left to the right. It might curve, but that's okay. And then neither would be anything but, meaning it's broken, but then also connected some places. Discrete is not connected at all. Continuous is all connected. Anything else would be neither. So a combination of the two. There are some problems that you'll have to explain in your homework, so you can refer back to these definitions. So it's a discrete function. If you had to explain, you say the points are not connected. So you can come back to these reasons if you need to. Any questions about it? We don't really need to focus on the domain and range for these just yet. We will later. So we'll probably come back to that table eventually. So what type of graph is f of x?
Continuous.
Continuous. Okay. If you had to explain, what would you say?
Because all the points are connected.
All the points are connected. Okay. What about g of x? Neither. Why? Some connected and some aren't, but the graph is broken, so it can't be continuous, and it's not discrete because a couple of them are connected. And h of x? Discrete, because? None of the points are connected. Now, if this was your homework assignment, you do not need to copy down the graph, okay, unless you would like to, but you do not have to copy it down. So if it said explain, I should say continuous in your explanation. If you want to copy down the graph, you may, but you do not have to if it is a graph. If it is a table or an equation, yes, you do. Okay. Now with word problems, you would need to be able to distinguish that relationship with or without a picture of a graph. Okay. So as a private investigator, TIA charges $25 per hour for any amount of time up to 8 hours, and then a flat rate of $250 per day. Use the graph to determine if the function that models the situation is continuous, discrete, or neither. Based on the picture of the graph. What is it? Neither. Why?
Because one connects to the rest of
Okay, there's one connection. Now, why is it connected in the word problem? What tells you?
Because of flat rate.
The flat rate of $250 per day is, here's 1 day, 2 days, 3 days, 4 days, 5 days. So it's before that. So why is there a little line connection here in less than a day?
Because she jumped from there.
Well, there's a jump from there, but why is it connected from 0 to that point?
per hour.
Okay. It's saying 25 per hour for any amount of time up to 8 hours. So could that be 30 minutes? Could that be 7 hours? Okay, so that's any in between versus the others are just whole days. Okay, it's not a day and a half, it's just 1 day. If it goes beyond 1 day, then it's an extra $250. So that's what the flat rate means. That's gonna jump $250 every day, but for the first 8 hours, any time in there is that 25 per hour, which is why it's connected. So if I didn't give you a picture of the graph, that would tell you it's neither, because there's some connection between those points. Question about that? If you have a picture, obviously go off of it, but sometimes you won't. Okay. It also should be discrete if it's talking about certain units. Like if we're talking about you have to have a certain number of cars for so many people, you can't do half a car for half the amount of people. It's still a car. Okay. So just think about the units if it's a word problem. Questions before we move on to our second topic for the day? Are we finding this easy? It was supposed to be. Okay. So now we're gonna talk about linear versus nonlinear. A linear function is a function that has a graph that is a perfectly straight line. Will not curve. Okay, that's what linear means. Now this is kind of a side note. If the domain of the function is all real numbers, the function would be continuous. So it can still be linear if it's a discrete graph, that they're all just in a straight line. So it doesn't necessarily have to be connected. A linear equation can be used to describe a linear function. Technically the same thing. An equation is like these. Linear function is technically the graph of it, but either way it's fine. So if linear is a straight line, what do you think nonlinear is?
Not a straight line.
Anything but a straight line. So it would curve, okay? Or if there were specific discrete points, it would not follow a straight line. Okay. So if you flip back to graph h of x on the front, half of it is linear, but it does change direction. So on this one, it would be linear to this point, but then it changes direction. So this is still a nonlinear graph. It would have to be a straight line the whole way through. So it doesn't have to be connected. All right. And then obviously graph A would be nonlinear because it curves. Okay. So you may not always be given pictures or graphs for these. So you need to know how to interpret an equation without actually doing anything with it to determine if it's linear or nonlinear. Now, what makes a function linear and what the actual word linear means is that the highest power of x is 1. Okay. So for example, this first function is linear because that is an x to the first power. Now, a 1 does not have to be there, but any other exponent has to be. So this is linear because the highest power of x is 1. Okay. Now this question came up last hour. Isn't that in y equals mx plus b? Yes, it is, and that's coming. Okay, so if you have that prior knowledge, that's great. But the specific thing that makes this a straight line is the highest power of x is 1. Okay. So over here, would this be linear?
No.
Why?
Because
Because we have a power higher than 1. If that was not there and it was just 3x plus 6, then yes, it would be. But as soon as you add an exponent larger than that, that would be nonlinear. And there's lots of types of nonlinears, and we'll get to specifying those later in the year. This would be a cubic function because that's x cubed. Okay. But right now I just need it's either linear or not. Okay. What about f?
Linear.
Is that the same as it?
No.
So he's saying no. What's different?
X itself is a power.
X is the exponent. Okay. So this is not linear. Okay. The x has to be the value of a whole number, basically, and it has an exponent of 1. This is a 4 with an exponent of x. So if the x is small, it is not. Okay. This is a nonlinear. That's actually called an exponential function, meaning x is the exponent. It starts out flat and it makes a spike. Kind of like when the start of COVID, if you watch the news, it was like, because everyone was catching it very quickly. So that is a nonlinear one. Okay. A cubic one, so that. Okay. This would be a straight line. What about G? Actually, no. The reason being, some of these may show up in your homework. Do you see any like terms?
Yes, 2x.
If you have more than one x squared, they need to be combined together. Now, if you have a 2x in parentheses squared, you would square the 2 and square the x. So what is this actually?
4x squared.
A 4x squared. So if you were to rewrite this, and you may have to do this in your homework, that's a 4x squared minus a 4x squared plus x plus 1. So you may have to simplify it first to see if it's linear or not. Now what's 4x squared minus 4x squared? 0. So really this function is just x plus 1. So that would be linear, because the highest power in the simplified form is 1. So in your homework you may have to simplify first. Most of them you won't, like the first 3. It just is what it is. But you may have to simplify first. Okay. So if you see any like terms, move them around. Also make sure y is on one side and everything else is on the other. Okay. But I picked ones that generally weren't that crazy. Okay. So linear is x to the first power, and that's the highest. Does everybody understand the difference between this one and this one? Just because there's an x there, x is the exponent that is going to start curving it. Okay, so be really careful with that. Your other option would be to start plugging in numbers for x and then graph them to see if it's in a straight line. But if you can remember these aspects of the functions, then you shouldn't have to do that. Okay. Are we good to move on? All right, so now we're going to interpret it through a table without actually graphing. So situation where this information comes from, area A in square inches of a pizza is a function of its radius R in inches. The cost C in dollars of the sauce for a pizza is a function of the weight, W in ounces of the sauce used. Given the table for each function, is each function linear or nonlinear? Now this is without graphing. Technically you could graph it and see if it's in a straight line or not. Okay. But I actually want to show you what you're looking for. Now, the radius is the independent variable, which would be like the x value in this one, and then the weight is over here. Are those increasing by the same interval as you move through the chart? What's it increasing by? 2. So from here to here, plus 2, plus 2, plus 2, plus 2. You at least need to check that. Your main focus is going to be on your either y's or your range values. Okay, but you need to make sure that these, before you even try this way of interpreting it, you need to make sure these are increasing or decreasing at the same rate, okay, for it to be determined this way. So usually it's by ones, but occasionally it's by twos. Just make sure it's by the same. Okay. Now your main focus in determining this, once you figure out that that is, excuse me, that is going up at a constant rate, then our focus will be on the other variables. Bless you. Now, I don't even need to know exactly how these are rising. Approximately 12.5 to 50 is an increase of how much? Approximately. It's about 37 and some change, but so if you want to write 37-ish, that's fine. All right, approximately 37. What about from 50 to 113? 67. No.
87.
It's about 62 and some change. Okay. You can find the exact ones if you want to. So 62 point something. About 113 to 201 ish. 86, 87, around there. What about 201 to 314? 113. Okay. So you can write the exact values if you want to. So if you have your calculator nearby, you can do that. But a linear relationship is 100% constant. Meaning it is increasing by the exact same number every time. Is that taking place? In the x column it is, but in the y column is it? No, it's increasing by 37, then by almost double that, then by a little bit more, and then it makes a big jump to 113. So what this graph would be doing is it starts out lower values and it starts jumping, so it's going to look like that exponential function that I did. Okay, so this is a nonlinear function because that is not a constant increase. It would have to be by the same number for it to be linear. Your other option is to actually graph them and see if they fall in a straight line or not. Okay. But if you can look at a table and identify how it's changing, if it's a constant change, then it's linear, meaning it's the same number being added or subtracted every time. So the second table, what's the increase of the first two? 80 cents. 160 to 240. 80 cents. Now it looks constant already, but you need to make sure it's all up, because it might curve at the last second, so you have to make absolutely sure. Now it is plus 80 cents the whole way, but you need to make absolutely sure, because it might change on the last one. Okay. Yeah.
Does on the pizza one, how's this area inches squared? Does that also say it's not linear because they're not supposed to be squared?
Correct, because area is squared, so that's going to involve squaring something. So that would be a hint also. But say I just gave you X and Y, and you didn't have any background information, then you'd see how the Y values are changing. So this one would be linear because why?
Cause it doesn't change.
It is a constant increase. So, in your homework, if there's a graph given to you, you do not have to recopy it. If there's a table, yes you do, because I wanna see this, how it's changing. If it's an equation like the previous four, yes, write it down and write what type it is. Any questions about linearity? Easy today? That was the hope, but keep in mind you might have to explain, so refer back to that first table if needed.